All right, welcome to Unit 7, and we're going to continue with linear equations. But this time, we're going to be looking at a system of linear equations, okay? So a system means you have more than one equation, okay? So in this case, we have two, okay? So graph these two lines here, it says, on the same grid. So here we have two linear equations, and we're going to graph these two lines. And again, as long as you have more than one equation, so two or more, then that's a system, okay? So in this case, it's a linear system because both equations are just lines. Okay, so we are going to graph these two lines on the same grid and go from there. Okay, so here's my x-axis, here's my y-axis. Now, if I want to graph, I typically would like to turn these two equations into slope-intercept form. So that means I need to turn this into mx plus b. So I'm going to move x to the right, so that's negative x plus 8, okay? For this one, I'm again doing the same thing. I'm going to move the x to the right, so that's negative x plus 2. But I do need to divide it by negative 2 here to isolate for y. So negative x divided by negative 2 is now just positive x over 2. You can write that as 1 over 2x if you wanted to. Okay, so it's the same thing, 1 over 2x or x over 2. 2 divided by negative 2 is negative 1. Okay, so I'm going to graph one with red and one with some other color, okay? So here for the first one, negative x plus 8, actually by the good look of the graph, I might need to move the x-axis a little bit lower here. Okay, so the the y-intercept is 8. 1, 2, 3, 4, 5, 6, 7, 8. And the slope is negative 1. Again, that means I'm going to go one down and one right. So here we go, one down, one right. I'm just going to plot as many points as I can. Okay, so here we go. And now for the second line, I will graph this in green. Okay, this one in green. So the y-intercept is negative 1. And the slope is 1 over 2. So I'm going to go 1 up, 2 to the right, 1 up, 2 to the right, 1 up, 2 to the right. Okay, I forgot to join the points for the first line. But here we go. Here's my second line. And for the first one, again, you should do it with a ruler, okay, just to get the accuracy of your graph. But there you go. Here's your, I guess that's the first line, and the green one is the second line. Okay, so there is the linear system, okay, on the same grid. Now here it says, if we want to solve a linear system, okay, what does that mean? Okay, it says to solve a linear system is to determine all the order pairs x and y that satisfy both equations. Okay, so recall when we solve an equation, essentially what we're doing is we're solving for x such that if we plug in that value into the equation, both sides of the equation will actually equal to each other. Okay, now in a linear system, in this case, we have two equations. What we want is we want to find all the order pairs so that the x and y values, when we plug into the equations, they will actually make sense, okay? So I will show you what that means in a bit, but here, let's continue to read here. It says, by graphing both equations on the same grid, if the lines intersect, that means the point of the intersection satisfies both equations, and that gives us the solution of the linear system. So if you look at this example here, this point right here is the point of intersection, and this point has a coordinate of 1, 2, 3, 4, 5, 6. Oh, hold on, let me double count. 1, 2, 3, 4, 5, 6. 6 comma 2. Again, this means x value is 6 and y value is 2. Now, what I'm going to do is I'm going to plug in these two values into these two equations, okay? So x is 6, so for the first equation, x plus y is 8. So I'm going to put 6 into x, I'm going to put 2 into y, and indeed 6 plus 2 is 8. And I'm going to do the same thing for the second equation. It is x minus 2y equals to 2. So again, x is 6 minus 2 times the y value of 2, and we get 6 minus 2 times 2 is 4, and that equals to 2. And that also makes sense. Now you see, this point actually, when you plug in these two values into these two equations, it actually makes sense. And that's what it means to be the solution of this linear system, okay? So we can solve by graphing. As long as we can find a point of intersection, that point is actually the solution to the system. Okay, so that's what it means to solve a linear system graphically. Okay, so here's the practice question. Why don't you give it a try? Again, all you have to do is graph these two lines and then find out where they intersect, and that point would be the solution to the system. Okay? Okay, so let's see here. For this first equation, if I keep the y on the left and move the x over, you get negative y is equal to negative 4x plus 6. And now divide both sides by negative 1, you get y equals 4x minus 6. Okay, so I'm going to graph that one first. That's 1, 2, 3, 4, 5, 6, negative 6. The slope is positive 4, so I'm going to go 4 up and 1 to the right. Okay, so 4, remember, is 4 over 1. So rise over run, 4 up, 1, 2, 3, 4, and 1 to the right. 4 up, 1, 2, 3, 4, and 1 to the right. 1, 2, 3, 4, and 1 to the right. Okay, so again, you can use a ruler. It's hard for me to use a ruler on the screen, so I'll just do it freehand. Okay, for the second graph, I'll use blue this time. So I'm going to keep y on the left, and I'm going to move x to the right. So you get negative 3x plus 1. Okay, so the y-intercept is positive 1. The slope is negative 3, so I'm going to go 3 down, 1, 2, 3, and 1 to the right. 1, 2, 3, 1 to the right. That's perfect because I already get my point of intersection, so that's all I'm going to draw, or that's all the points I'm going to plot. And you can see this point is the point of intersection, and therefore you can say that the solution would be, 2 comma, no, sorry, 1 comma negative 2. Or you could say that x equals to 1 and y equals negative 2. Okay, you can always check your result by plugging these two numbers into the equations. Okay, so I'll do it for both. Let me do it with the blue ground first. So x is 1, so 3 times 1 plus the negative 2 equals to 1. That's 3 plus minus 2 is just minus 2, or plus the negative 2 is just minus 2. And for indeed, that makes sense. If you do it for the first equation, we have 4x, so 4 times 1, minus y, which is minus negative 2, equal to 6. So 4 times 1 is 4, and minus the negative 2 is plus 2, and that equal to 6, and that also makes sense. So we can guarantee that this is indeed the solution. Okay, so that's how you solve by graphing. Now we're going to see some more problems in this unit. Okay, so here we go. Let's take a look. It says John works at a computer store, and he is offered two methods of payment. Okay, John at a computer store is offered two methods of payment. Plan A, or the first offer, I guess, is that he gets $700 a month plus 30% commission on total sales. Okay, so commission, if you don't know what that means, it means that if the more you sell, the more money you get. So for example, 30% commission means if you sell something for $100, you actually get $30 from that sale. Okay, so you actually earn $30 from selling $100 of a product. Okay, or maybe just more than one product. Okay, but you get 30% back. Okay, plan B is you get $1,000 a month, but in this case you get less commission. Okay, only 20% on total sales. Okay, so first of all, you need to come up with a linear system to model this possible situation. Okay, to model his possible monthly salary. So I'm gonna say that so anytime you do these, you should name your variable first, right? So we say let S represent total sales. Okay, so that'll be in dollars, right? So if you sell $100, then S will be 100. And let T represent the salary, okay, total amount. total salary. Okay, so to create a system, well, the total amount of money you're gonna receive for plan A is gonna be, well, $700 a month plus 30% commission. Now 30%, you need to convert 30% into a decimal, and that is 0.3. 30% on the total sales, so it's 30% of the total sales. And remember, earlier in your math career, you learned the word of means multiplying. So 0.3 times S. So that's plan A. Plan B, the total amount of money you'll receive is going to be $1,000 plus 20% commission. So 0.2 times S. Okay, so if you sell $100, then you get $30 for your commission plus the $700 that you make regardless of how much you sell. Okay, so this would be a linear system. You can see because it has two equations. Okay, now the next part is let's graph the system. Okay, actually I should probably do it in different colors. Hey, I'll do this one in blue for plan B. T equals 1,000 plus 0.2 S. Okay, now I already have the grid made here. I label them, x-axis is the sales and the y-axis is the total amount of money you'll receive. And they are both in dollars, okay? So for the first one, this, again, is just the slope-intercept form, right? mx plus b. We have y-intercept of $700, right? If you rewrite this, really, this is 0.3s plus 700 equals t. Okay, so my y-intercept is $700, which is right here. Okay, notice how I make each box worth 200. Make each box worth. Oh, that's right, 200. So half of a box will be $100. So 700 is between the $600 and $800 box. Okay. Now I need some more points. Okay, so I'm gonna say that for $1,000 that I sell. Okay, so you can find more points. So for this one, I can make a table of values. S and T, 1,000, 2,000, 3,000. I only make it all the way to 5,000, okay? Only up to 5,000. So to find T, you simply plug in 1,000. I'll show you one, and then I'll just do the rest without showing the work. But, right, if you sell $1,000, then that's what you put into S. 0.3 times 1,000 is 300 plus 700. This is $1,000. So if you sell $1,000, you actually make $1,000. So right here, our second point is here, 1,000 comma 1,000. Okay, if you do the same thing for $2,000, you are gonna make 1,300. This is gonna be 1,600. You see that? Notice how it's going up by 300 each time, and 2,200. Okay, so I'm gonna plot all these points, and then I'll make a line out of that. So 2,000 is 1,300. 1,300 is right here. And then 1,600, when I sell $3,000, that's right here. 1,900 is right here. Finally, 2,200 is right here. Okay. Now, because it's money, it's also, we consider money a continuous variable as well, so we're going to join the points. Okay. Now, I'm going to do the same thing for the next one here. Again, this, if you rewrite it, this is T equals 0.2S plus 1,000. Okay, so I'm going to make a table of values for the blue graph as T. Right away, I know that the slope, the y-intercept is 1,000. Okay, and I can make a table of values. Because the slope is 0.2 is not as easy to use in this large number grid. So, because I mean, you're going 0.2, you can write as a fraction as 1/5. You're going to go 1 up and 5 to the right? Not really with these big numbers. So I'm just going to get some values. Again, I'm going to go with 1,000, 2,000, all the way to 5,000, okay? And I'll show you the work for the $1,000, and I'll just plug in the table for the rest. So T should equal to 0.2 times 1,000 plus 1,000. And that will give us, oh, wait a second, that's 300. Why did I put 3,000 there? My bad. This is 200 plus 1,000, which is 1,200. Okay, so 1,000 and 1,200, and if you just keep going, this will be 1,400. You'll notice that it's going up by $200. Okay, so if I plot the points, 1,000 and 1,200 is here, 2,000 is at 14, 3,000 is at 16, 4,000 is at 1,800, 1,800 is here, and 5,000 is at $2,000. Okay, so again, if you join the points, you are going to get this line right here. Again, ideally, you draw it with a ruler. Okay, so there we go. Here are my graphs. Okay, now let's answer some questions here. Let's see. Now you can see the point of intersection. Oh, I completely missed the point of intersection, didn't I? Okay, let me redraw it, because it doesn't look like that's the point of intersection. Okay, so here, we should go through here. And okay, something like that. All right, now let's answer the questions. Okay, first question says, what must the monthly sales be for a clerk to receive the same salary with both plans? Well, if you want the same salary, then you're looking at a point of intersection, right? Because in that case, in both plans, you're making $1,600. So based on the graph, you need to sell $3,000 a month to make the same amount of money, okay? And that is $1,600, okay? To make $1,600, okay? The next question says, when would it be better for a clerk to choose plan B? Well, you can see that we have two graphs. Now, the red graph is actually lower than the blue graph at first. But after this point, the red graph actually exceeds or goes on top of the blue graph. So it says, when is it better to choose plan B? Well, plan B is the blue graph. And blue graph is better if we sell less than $3,000 because the graph is actually higher than the red. Okay, so if you, or if the clerk has monthly sales less than, less than $3,000, then plan B is better. In other words, if you sell more than $3,000, then you should stick with plan A. So in that case, it really depends on how, if you're a good salesperson. If you are, then you should choose plan A because you have more potential. But if you are, shy, not so much of an outgoing person, then you probably should choose plan B because maybe you will not be able to sell more than $3,000 worth of product. Okay, so that's it. That's the lesson. That's how you solve the linear system by graphing. Essentially, you graph both lines and you look for the point of intersection, and that point tells you that they are equal to each other at that point. Okay, there are some practice questions for here for you to do. Let me know if you have any questions. Good luck.